Hello there. Now let's look at another LeetCode problem. This is 141 linked list cycle. Given the head of the linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in a list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. Alright, let me read the question there. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Okay, example 1. 3, 2, 0, 4, minus 4, minus 4.22. Okay, so here the input is given as 3, 2, 0, minus 4, and we have pos equals 1, output true. Okay, I'm not quite sure what pos means here, so let's read the questions to make sure I understand the problem description. Internally, pos is used to denote the index of the node that tail's next pointer is connected to. Note that pos is not passed as parameter. Okay, so I think we can ignore the pos here. So let's see the explanation. There is a cycle in the linked list where the tail connects to the first node, 0 index. Okay. Okay. We got it. Second example, we have 1.2 to 0.1. Then this is true. Pos is 0. There is a cycle in the linked list where the tail connects to the 0 node. Example 3, we have 1. Pos is minus 1, return false. There is no cycle in the linked list. Okay. So I think I understand the problem now. We are given a linked list and we need to determine whether there is a cycle in it or not. I think I understand the problem now. I'd like to clarify a few things. One is the length of the linked list. Is it guaranteed that at least there will be one element? So here it says that number of nodes is between 0 and 10 to the power of 4. Okay. Can you solve it? The question is, can you solve it using O1 constant memory? Why? Um, okay, off the top of my head, I think what we can do is we could let's see. On a brute force method, we could store it inside a list. So as we go along the linked list, we could store each visited list into a list. And so, I think, right. So what we can do is we could create a visited set, and then as we move along the list, we add each of the set that we have seen into the set, while at the same time we can check whether we have visited it or not. Because if we have visited it twice, then there is a cycle. Otherwise, there is no cycle in it. Um, okay. Um, it actually, I actually am familiar with this problem, and because I have seen it. So one way to do it in O1 constant memory is to use two pointer. One is moving twice as fast as the other, and the slower one will move at will move one node at a time, and then there is another pointer that move two two node at a time. And if there is a cycle, then there will be a time when uh, both of these pointer meet each other. Okay, so let's look at the examples that we have here. Uh, all right, so before we move on, given the size of the head, we could come up with a edge case where there is empty list, right? So now let's go back to the example one. We have 3 to 0, 4. 3 to 0 minus 4 minus 4.22. So we have fast and slow. It starts at 3 and 2. And then the fast we move to 0. Slow we move to 2. And then the fast will move to 2. Slow will move to 0. And then fast will move to 4. The slow will move to 4. At this point they meet each other, so there is a cycle. Second example, 1.22, 2.1. Now fast and slow. Fast is 1, slow is 1. The fast stay as 1, slow move to 2. Fast still stay at 1, slow move to 1. So it meets each other. So there is a cycle. Third example, there is one only by itself. So pass will be starting from 1, so starting from 1 and then it become null. So there is no cycle. False. The last example is just an empty list. So fast and slow started at null, then there is no cycle. Okay. So how are we going to do this? First of all, we create two variables. One is fast and slow, both pointing at the head. Then what you're gonna do is while fast and slow are not a null pointer, then we check if fast equals slow, then they meet each other, meaning that there is a cycle. Else, fast we move to fast.next, and then slow will be slow.next. In the end, one of them either, if we satisfy the condition where one of them is null, where at least one of them is null, then there is no cycle because we reach the end of the linked list. So we just return false. Alright, let me go through the code again to make sure I haven't missed anything. We first create fast and slow pointer, initialize to the head, and then we keep on moving through the linked list using the fast and slow pointer. If they meet each other at any point, then there is a cycle because the fast pointer will catch up with the slow pointer as it is moving twice as fast. Otherwise, we move the fast and slow pointer in its own speed, respectively. Fast will move 2 pointers, and slow will move 1 pointer. I think this works. Now let me test the code with the examples that we have prepared here. So fast. Yeah, we actually go through it before, so I am pretty confident that this could work. Let me input our answer into LeetCode and see if we got it right. So fast and slow, starting at head, while fast and slow in fast equals slow, return true. Else, what we do is fast move to fast.next, slow equals slow.next. In the end, we return false. Wrong answer. Let's see. Output is true. Okay, so what do we do here? So fast is now pointing at null and also null. Okay, so faster next. Hmm, interesting. So we also need to check faster next. Otherwise, yeah, I think this should work. But now let me test with empty list. Yeah, got it correct. I think this should work. Yeah. Okay, let's try to submit it. Wrong answer. Output is true. Expected false. Hmm. What's the next? The next. I think we should check the next instead. So, how about this? Okay, we still got it wrong. So let's see what happened here. We have 1 and 2. First dot next still valid. Yep. And then first equals to s. Output true. Is that what happened? Let's see. The second iteration. Or instead of doing this, let's just debug it. So value 1, value 1. Okay, so they point at the same pointer. Do I always return true here? No. None. Do I need to check for none? What is happening here? Okay, I think I know. Um, okay. Yeah, it's a bit tricky. I think this is a hand edge case. Let's see what I can do. So basically, initially it points at the same pointer when we was in the first pass, so it doesn't make sense. Okay, so I think we can move this after we the first iterations. After the first iteration, then we can check. Yep. So this time we got it right. Let's try to run it. Okay, cool. Let's see other people's solutions. Um, we have rates analyzing rate being equal to data, upgrade to perimeter, increase accuracy, and further analyze. Okay, let's see other people's solution. What's right? What's in class next? Okay, pretty much everyone is doing the same thing. Right? Yeah, I think so. Because there is, yeah, I don't see much variation on this. I guess this problem is just quite well known to people. So, alright, let me stop it here. Thank you.